Hi, welcome to lesson 14, Dredging the Deep. Now we're up to the 1950s. And if you recall from last time, we've learned some pretty interesting stuff about the Earth's crust. Namely that the continental crust is much different than the oceanic crust. The continental crust is much less dense, and it's a lot thicker and variable than the oceanic crust, which is incredibly uniform and mostly around 6 kilometers thick. It's also a lot more dense. It also has that weird property of having this big mountain range down the center of most of the oceans, and it has that cleft in the middle of the mountain range. Further research on the ocean floors, which really was the next step in earth science, was difficult. It was expensive and really technically challenging, because just the physical nature of studying it means you have to contend with open ocean, relentless weather, and once you get off of the continental shelf, it's incredibly deep ocean, 2.5, 3 kilometers deep. So it wasn't easy, and it was expensive, and it was hazardous. Just getting to the center of the Atlantic to study the mid-Atlantic ridge, you have to go 2,000 to 3,000 kilometers in places, and that's really just halfway across the Atlantic. So funding these expeditions and actually carrying them out was no small feat. But since it was really the next area of research in earth science, it did cause some excitement, and these expeditions were undertaken, luckily. It wasn't until 1964, when they put the deepwater submersible Alvin into commission, that anyone could even look that far under the ocean. Until then, the mysteries of the deep were just that, mysteries. So how did these early expeditions study mid-ocean ridges? Well, they went out in the ships, and they didn't have any remote sensing. They didn't have cameras on submersibles or remote control, whatever. They didn't have Alvin at this point, the deepwater submersible. What they had were very long lines with chain buckets on the end, which they would drag across the bottom of the ocean. Now they hoped to pick up the odd rock that had come loose and bring it up to the surface for inspection. This was really dangerous and somewhat difficult because they were really in the dark, letting all that cable out kilometers and kilometers. If it got stuck like a fish hook in the weeds, you ran the risk of tensioning it and breaking it. And kilometers long tensioned cable is not something you want to break, and it was pretty dangerous to be on deck of these ships. Apparently they would sit on the coils of the line just to feel the vibration of it to make sure it was still dragging and not stuck. It's pretty low-tech stuff. What they brought up were these incredibly heavy, dense, black, basic, young volcanic rocks, pillow basalts. These so-called pillow basalts have an interesting property of having glassy rinds. It's a characteristic of underwater volcanic eruption. But that's not the only interesting thing about pillow basalts, and in particular mid-Atlantic or mid-ocean ridge pillow basalts. So next time I'd like to go over some other interesting properties that these pillow basalts have.